So the next video or two is going to be devoted to some more theoretical topics that up to this point we can sort of avoid. Um, we launch a game, we want to find a value, we search for it, we find it, we change it. That's great. Everyone's happy, we're happy, the game's happy, so on and so forth. Um, Now the issue that we're going to start to get into is how to make sure that the values we find recur every time we start the game. So, we're going to go through this real quick just to demonstrate the point. Um, but as I'm going through this, um, it's worth mentioning that the next few videos are however long it takes me, or however long I feel it takes me to deal with this general topic. It is going to be a lot of theory and me talking, and it's probably going to be there'll be some instances where I'm clicking around and showing things, um, with the game and whatnot, but a lot of it is going to be just me talking, and that's unfortunate, because I maybe not the best at talking in the world, but in order to have things recur, or to be able to find addresses dynamically, whether you close the game and then you restart it and whatnot. I mean, there's a certain foundation that you have to understand, and if you don't understand that foundation, or you're operating outside of it, then you might have no idea what's going on, and it'd be extremely difficult for you to figure out. So I mean, if you wanted to, you could probably skip ahead, the next few videos until we start getting into pointers and stuff like that. But I wouldn't recommend doing that. But I'm not going to tell you what to do. So obviously that's at your discretion. But I highly recommend, if you don't want to just listen to me, then go on Wikipedia and read about a couple topics, which I'll list on the desktop in a minute, so that you could shut this video off and just go read, and hopefully you don't have to listen to me, but you could just read what they write on Wikipedia. But to illustrate the point of what I'm talking about is, we'll do what we've done in the previous videos here. Did I not have? Yeah, cheat engine's not open. So open it up, attach to the process, the usual nonsense. I don't even know what. I think it's 34. Was it 34? It was. So let's 32. It's not great. I don't know, 31. And just to be safe, we'll do a big jump in the value 6. Excellent. So we have these two values. Let's make this one 55. Go back to Shadowrun. Spend a point. That's not it. There you go. So karma value during character creation. Karma value for new player. I type often. Alright, so again, it is stuff we've all done before. We can do it a couple more times. So we know we have 95 karma available during character creation, and we know that the new karma when we start a game is going to be 29. So let's do that. Start the game. What etiquette? Let's go with socialite. I quite fancy that. Mr. Fancy Pants, because we're socialite after all. The game does its thing. And I've, that's, well, yeah. Hit continue. PDA, 29 karma. Spend karma. You can see it really is 29. Let's close the PDA out. Exit, exit, exit. Yada, yada, yada. It's a pretty decent looking elf. 55. Open the PDA back up. 55 karma. Alright, everything is in order, and it is how we expect it to be. So, what do I mean when I say we want to have be able to find addresses when we restart the game? Well, these are absolute addresses relative to the actual process. So 209E3230, that's an address relative to this process, or relative to Shadowrun.exe. Shadowrun, the process Shadowrun, as we were talking about in one of the first videos, has a block of memory associated with it, and these addresses are all relative to that block of memory. This is not an absolute address in the computer's RAM or something like that. And I'll dive into more detail about it as soon as we're done proving the point here. But basically, uh, if you restart the game, which we'll do in a minute, these addresses will be meaningless because the game, every time you restart this game, it's reallocating huge chunks of memory, and the addresses will always be different. So obviously the reason it does that is because if you close down this process, say you exit the game, you exit Shadowrun, it's simple logic that Shadowrun should obviously give all the memory it was using back to the computer. Um, and I don't think I have to explain that any further. So let's demonstrate this. Go here, we exit. Yep, we're done. We don't even have to exit the game. To prove the point, we just exit it back to the main menu, and maybe I'll cycle through it again. See the value is still 55. We'll start a new character. The values are the same. Yep. Stuff. Great. I'm not even going to mess with the values. I'm just going to confirm it and go. For brevity, if one might say. We're an academic, so let's call ourselves Donald Knuth. Alright. So we go here. See these values are still the same. Go up to the PDA. We have 5. We have 5 karma. So I mean, this illustrates the point that you don't even have to restart the game, or you load a different game or something like that. It's letting the program Shadowrun is essentially just forgetting about these addresses, and it's reallocating new chunks of memory and assigning new, as far as Shadowrun is concerned, it's assigning new meaning to different addresses because the player that we found these addresses relative to a player we created, and then we exited back to the main menu and created a new character. So these addresses are not assigned to our current character, to our new character. So just to crystallize that a little bit more, let's make that 999. Let's make this 999, and if the thing doesn't crash, we'll be able to see that it does nothing. You go in here, you could reset the menus as much as you want, spend some karma, there you go, it's down to 0, add 0. So these values not relative to our new character. So let's make the example or take the example a little further. Go back to the main menu, we will exit the game. And you can see that Cheat Engine was attached to this Shadowrun process, and down here now it just has a question mark. Because these values don't exist because this process doesn't exist. If you're running Windows, you can right click and go to Task Manager, and you can pull it up, and you can see that obviously Shadowrun.exe does not exist in this list at all. So the Cheat Engine is basically telling you that I can't find the process, so obviously I can't find this memory address relative to the process because the process does not exist. So if we minimize that, we'll relaunch the game. Go to new, go to launch campaign, the usual jazz, things, stuff, profit. Yep. Alright. That's not it. We can close that. It's a little task list that I'll go over in a minute. It's a task list is what I meant to say. So again, Cheat Engine now, even though we have Shadowrun running, is saying I can't find this process at all. Well, why not? We have the name right here. The reason is because every process has we'll just call it a value, but there's more. You get deeper than that, but it's left as an exercise to the viewer. So we have 4A0 was sort of the identifier associated with Shadowrun.exe when we had this running before. So let's reattach it. If you go here and it will open up this list, and what do we want to attach to? We want to attach to Shadowrun.exe. Notice the identifier is different. So it's not just in the name of the process. You could have 10 Shadowruns running, and they could all have the same process name, but this identifier over here on the left is always going to be unique. There's a whole slew of technical reasons for it, some of which I'm not really a Windows programmer, so I'm sure there's a reason. But whatever the case may be, this number on the left, or this value, it's hex, but this hex value on the left is always going to be unique, and this name on the right can be whatever the hell you want it to be. It doesn't matter. Let's scroll up here a little bit and see if we can find two processes that have the same name. So here's an example. We have service host.exe. We have lots of copies of this running. This is an internal Windows process. Same name, but all the identifiers over here on the left are unique. Because when you're attaching to a process or you're referring to a process, it's internally the computer's not using this name over here on the right. It's using this value over here on the left. So this value on the left side of the hyphen, always unique. On the right side, doesn't really matter. It can be anything you want. So we're going to attach it to this instance of shadow1.exe. Do we want to keep the current address list in the code list? Yep. What does that mean? It means that we want to keep all the stuff that we have down here, so that when we attach to the new process, Cheat Engine is going to say, all right, I'm going to immediately index into the memory associated with this process by this address right here, and then the value of that is over here. Now, because, as we saw when we didn't even restart the game, we just rolled a new character, but now that we've attached to a completely different process, these addresses they're not just meaningless, they're something completely different. And if you start poking values into, after you restart it, and you just start putting values into arbitrary addresses like this, I mean, you're going to crash your game, because it's not just that this value doesn't mean, or is not what it used to be. It's that this value doesn't mean what it used to be. This is no longer, probably this is not a karma value. This could be some internal routine or a Boolean flag or something. I don't know. Let's see if we can crash the game. We'll just set some ridiculous thing. Okay, it can't parse it, so I don't know. We'll just make it a little smaller. There you go, 9,999. We'll exit around, click around a couple menus. Can we crash the game? I don't know. Seems to be working all right. But anyway, the point's been made that, it lost the process. I don't know what the value is. So this is sort of the jumping off point. We'll go over this in some more detail in the next video. I mean, it's been 12 minutes so far, so I have a feeling it might be a series of videos. But what we're going to go over is basically 4 essential points. And the first, we'll expand this a little bit, is that memory is dynamic, and we just illustrated that through the exercise we just walked through. So absolute address values, such as what we've been messing with up to this point, are meaningless when you either go through or force the game to load a different instance, like a save game or something like that, or you restart the game. Is the more quintessential example. That absolute values mean nothing. They're just values, and the game is free to put those values wherever the hell it wants, and they do. The second thing that we're going to go over is the stack, or the call stack, if you want to be technical about it, and we'll get into what that means in the future. But we're actually going to put these two together. We're going to go over the stack and the heap, because there's an important distinction between the two. Now, I'm not going to turn this into a computer science lecture, but in order to effectively write scripts and pointers and values and things like that, we need to have at least a basic understanding of these two concepts. And so there'll be a whole lot of me referring to Wikipedia and saying, you could look up this, you could look up that, because again, I'm not gonna jump into a computer science lecture. But anyway, we're gonna go over in more detail that memory is dynamic. Then we'll talk a little bit about the stack, talk a little bit about the heap, and then we will get into pointers. And this final topic here, the pointers, that's what's going to allow us to find values dynamically, no matter what the process, and whether we shut it down and restart it 1,000 times. We will have pointers with offsets and things like that, and it will allow us to find values no matter what. So we'll find the pointer once, and then we'll put it in Cheat Engine, and we will always have that value unless the game is updated or the actual the code for the game changes. But anyway, I'll jump into this a little bit in the next video.